Today we're going to look at how to graph compound inequalities on the number line. And when we're talking about compound inequalities, compound means you've got two things that you have to worry about at the same time. So those inequalities involve the situation and the situation or. So when we talk about and, either this thing over here is going to happen and this thing over here is going to happen. Both things have to happen at the same time. And in the other situation, either this thing over here is going to happen or this thing over here is going to happen. So one or the other is going to make the equation true. So, or the inequality true. So let's just jump right in and let's start with and. When we're looking at and inequalities, both of the statements, both of the inequality statements have to be true. Not one or the other, but both of them. So when we have an example like this, -2 is less than x is less than 4, you can see there are two inequality symbols written in the statement, right? So that's what makes it compound. Now those two inequality symbols lead to two different statements. So we have this statement right here, -2 is less than x, and we have the other statement right here, right, that leads to this statement, x is less than 4. Now usually when you write an and statement, we always write the smallest number on the very left, and then we write the bigger number on the very right, and then x, or your variable, is usually in the middle. That's not always the case, but that's usually the case. And that's what we're going to see even when we solve equations, and we might have x's everywhere, but we want to get them to that place where x is in the middle. Okay, so if we look at these two inequalities right here, I'm going to stick with red for the first one. -2 is less than x. Remember, another way to say that is x is greater than -2, and it's strictly greater than. So if we went to our number line, I guess we need some values here. So let's say that's 0, then -2 would be right here. So we would put an open circle at -2, and then we would shade to the right because we want all of the numbers that are bigger than -2, right? Now if we look at that second inequality, we have x is less than 4. And we already have the x on the left, so that's pretty easy. We want all of the numbers that are smaller than 4. So going to my number line, 1, 2, 3, 4. 4 would be right here. And again, it's strictly less than, so that would be an open circle, and we would shade to the left. So those are the two graphs for these two different statements that we have. But then if we wanted to construct the graph of the and statement, where x is where -2 is less than x and x is less than 4, what we're just looking for is this green part that I'm going to do, which is just all of the stuff in between -2 and 4. So now let's answer this question. What are some solutions for this inequality? Well, any number that's in the green would be a solution to this inequality. So for example, 0 is a solution. Put that down here. Because -2 is less than 0 and 0 is less than 4. That's a true statement. 1 is a solution to this inequality. -2 is smaller than 1 and 1 is smaller than 4. Okay? Both of those statements have to be true. Now let's just do one other quick example. We can do this all at the same time. We see that my inequality symbols are facing the right direction. We've got the small number over here on the left. We've got the big number here over on the right. So small number is less than middle number, which is less than the big number. That's perfect. That's what we want. And then so we'll just go ahead and plot some of these values here. I'll put 0 there. 1, 2, 3, 4, 5 would be here. And so in this case, I have 0 is less than or equal to x. That's like saying x is greater than or equal to 0. So that would be a closed circle here at 0. and we have x is less than 5, so that would be an open circle here at 5. And I'm just going to shade everything in between. So another thing that you might want to think about when you have an AND situation, you're always going to be graphing between the two endpoints. So you're going to find those two endpoints and then graph all of the values in between them. Okay? Now I just wanted to go over something weird here, something that I would like you to watch out for, especially when you get into solving your equations. You might end up with a situation like this. Now if you notice, 3 compared to -4, 3 is a bigger number, -4 is a smaller number. And the other thing that's not so good going on here is my inequality symbol is pointing so that the larger number is on the left and the smaller number is on the right. Now there's nothing wrong about how this is written. This is a correct statement. It's just not how we usually write it. You know, just how we usually read left to right, and on the number line, small numbers are over here and bigger numbers are to the right. It's usually how we want to write our inequalities. It makes it easier. So for this one, I would rewrite this by saying -4 is less than or equal to x, which is less than or equal to 3. And then I would plot it. So if I put 0 there, let's see, 3 would be here, and -4 would be there. Looks like both of these are less than or equal to's. So closed circles, and then I would shade everywhere in between. Great. All right, so now let's look at the OR situation. OR is always going to have the word OR in it. We can't write it as a single inequality like we did in the previous examples where we just had that one statement. Here we have to have two different statements. So here in this example we have x is less than -2 or x is greater than 5. So if we looked at our number line, let's say here's 0, here's -2, and then 1, 2, 3, 4, 5. Okay, barely fits. Here's 5. If we graphed that, x less than -2, strictly less than, so open circle, and we would shade all of the numbers that are smaller, because that's less than. And then for the other one, x greater than 5, again, open circle, and we would shade to the right. So what we're saying here is x can be anything that's in the red, or it could be anything that's in the blue. It doesn't have to be both at the same time. It could be one or the other. So now if we want to talk about what are some solutions for this inequality, anything that's in the red or the blue would be a solution. So for example, -3 is a solution. -3 is less than -2. 6 would be a solution because 6 is greater than 5. Now, let's look at one more example here. What if I have x is less than or equal to 1 or x is greater than 2.5? So I'll put 0 here. That would mean that -1 is here and 2 is here, so that means that 2.5 is right about there. Okay, so we'll do closed circle at -1 because it's or equal to. We'll shade to the left. We'll do open circle at 2.5 right in between there, and we'll shade to the right. Perfect. That's all there is to it. I did want to go over a couple of sort of weird, sort of interesting examples. So let's look at this one. If we have 5 is less than x and x is less than -2. First of all, let's think about what this means. If I have 5 is less than x, that's like saying x is greater than 5. And since this is written all together, this would be an and x is less than -2. If we go over to our number line here, there's 0, 1, 2, 3, 4, 5 would be there, -2 would be there. So let's see here. If I have x greater than 5, that would be all of these values. And if I have x less than negative 2, that would be all these values. But this is an AND situation. There's no numbers that are both less than negative 2 and greater than 5 at the same time. So since there are no numbers that can be in both of those areas at the same time, there's really no solution or no numbers that make this inequality true. It's basically an incorrect statement. It's kind of like saying 1 is greater than 4. Well, that's not true. That's false, right? Here, there are no x's that are both bigger than 5 and smaller than negative 2 at the same time. All right, let's look at the next funny example. What if I have x greater than negative 2 or x less than 3? All right, so again, let's get a 0 on here. Here's 0. Here's 3. Here's negative 2. So let's look at the two statements. X is greater than negative 2. Or x is less than 3. So that would go like this. Now what's interesting about this one is usually when we have an OR situation, an OR situation will have kind of this picture, and there'll be some sort of space in between here. Looks like a smiley face. But there'll be some kind of space in between those two. Here we don't have a space. It overlaps, right? So since it overlaps, we could have anything that's in the green, and we could have anything that's in the red. And since it could be either one of those things, that's really all real numbers. Any x in the whole wide world would satisfy one or the other of these two statements. It covers the whole entire number line. Now let's look at one last interesting situation. Here we have x is greater than negative 2, like we did before, or x greater than or equal to 0. So let's get my 0 on here, negative 2 on here, and we'll graph the two things. So x greater than negative 2 we'll do in red. So open circle, graphing that to the right. And x greater than or equal to 0 we'll do in green. So that's closed circle this time. But it's greater than, so that's numbers bigger than 0. So again, that's to the right. Now if I'm looking for x's that are one or the other of these, let's do that in red. If we just want to kind of simplify the values that would make this true, it could be either the red or the green, right? But since the green is entirely in the red, well, really this simplifies to just all numbers that are bigger than negative 2. We really don't need this part to identify what x's we're talking about because it lives entirely inside of the other one. So that kind of simplifies to just the statement x is greater than negative 2. So I just wanted to show you those so you could be really thinking about what your inequality statement is saying and how you're going to graph it, and then how you could simplify it and figure out what kinds of numbers actually satisfy the inequality that you're working with.